Hello everybody, welcome to this webinar on PAS 2035. My name is Abigail, I'm part of the MACE Consult Net Zero Carbon team and I'm an architectural manager here. I have a passion for all things retrofit, so I hope this is an enjoyable webinar for you all. So yeah, firstly, PAS 2035 is to encourage retrofitting of dwellings for improved energy efficiency. How I'm going to structure this webinar is, firstly, I'm going to introduce you to a little bit of the context around why PAS is important and paint a little bit of hopefully a bigger picture. I'm then going to run you through what PAS 2035 means, how it's broken down into the roles and responsibilities, the approach to retrofit, the outputs, and finally the what a design report would look like. I'm then going to finish this off by running you through 3 case studies of how we would approach retrofit for those property types. Okay, so firstly, a little bit of context. This is a well-known statistic, so you may have heard it already, but 80% of the UK's 27 million homes are likely to still be in use in 2050. These are some of the least energy efficient homes in Europe and account for 28% of the country's energy use. To meet the current net zero 2050 targets, we need to be aiming to retrofit 1 million homes per year. It's important to note one of the reasons that the UK has such a big challenge is that our building stocks are some of the oldest, hence the need for retrofit and refurbishment. So there is a big need to retrofit these dwellings, but as yet the progress hasn't really accelerated. It's been quite slow, and there's been a few failed policies around this. One of them, probably most well known, was the Green Deal. So just to kind of give you a little bit of an introduction of why the context is as it is. At the moment, there's a little bit of a lack of tradespeople who are specialised to do some of the retrofit measures. So potentially in the future, there's a great opportunities for some jobs in retrofit. Retrofit has gone wrong. It is complicated, and this is the reason for PAS. And hopefully you'll get a little bit more of understanding of that as I run you through this presentation. But yeah, there's a little bit of lack of trust of homeowners, which we need to get back. There's been failed grant funding, e.g. the Green Deal, as I mentioned. And often it's not a cheap thing to do to retrofit properties. And there's a bigger, wider question around carbon savings and values of society. But yeah, at the moment, we need to weigh up the cost of install versus payback measures. Okay, on the plus side, it's a really, really, really great opportunity to create lots of jobs for the economy, particularly at the moment with the increase in price of gas. There's an opportunity to reduce your household bills and also as a byproduct reduce their household emissions, carbon emissions. There's a lot of not documented enough, a lot of deaths due to cold homes. So this should hopefully prevent some of those premature deaths and to protect the longevity of our building stock and our historic buildings, which are obviously very, very valuable. So yeah. So this is just a few kind of areas where retrofit has gone wrong. So this is put in not to scare anybody, but just to show the importance of running through PAS 2035 to make sure things are done properly. So the first image there is external wall insulation being removed. In this instance, it's been installed off a cement-based, because it's been installed onto a cement-based render onto a solid wall. Typically, these walls need to breathe. The render and then also this installation, external wall installation, will be preventing that and the likelihood that will cause problems in the internal environment. So again, a very expensive mistake going on there. The second is a damp problem, which is on a modern cavity wall. So cavity wall insulation has been retrofit. It is very important to know details about the build-up of the walls of your property. In this case, it's likely either the cavity width or the exposure zone wasn't considered enough, and then therefore moisture has penetrated the envelope, causing damp on the internal face. So if you have the correctly trained installers, this should be prevented. And the last is a Essel's heat pump, which is great. We're 100% promoting to try and transition over to renewable energy sources, but we do promote a fabric first approach to retrofit. So that is so we can reduce the consumption of the dwelling before translating it over to an electric energy source. If we don't do this, it's likely that bills will become a lot more expensive and is not good practice. So that's a little bit of context. So what does PAS actually mean? And it's not a particularly simple process, but it's essentially an improved energy efficiency specification and guidance for dwellings. This has been developed because of what I've just run you through after the Each Home Counts report, which was published in 2016, focusing on how these retrofit projects were being delivered. So with PAS, this should essentially protect the homeowner and put accountability onto those doing these works to ensure that they're being done properly and that homeowners aren't going to end up with problems later on down the line. The idea is to make it simpler and more transparent, looking at a whole house approach so that measures aren't being done independently and not considering the whole building fabric. When I say this, what we're really describing is on a building site, you could have multiple trades. You can have your electricians, you could have your installers of insulation. Everybody is their specialist in their own independent part. However, what PAS really needs and what retrofit needs is that coordination piece, that person who can understand what is going on with the whole project to make sure that those interactions aren't going to cause issues with other interactions and therefore problems with the build. So it's just important to know there's actually two PASs here. There's PAS 2035 and PAS 2030-19. These are actually locked together. PAS 2030-19 is essentially the installer's guide, what they need to be accredited to. So to manage this process, there has been a few roles divided to make sure that this doesn't go wrong. So I'm just going to kind of very, very high level introduce you to the different roles. The first is normally the retrofit assessor. So that is somebody who would have to have an assessor energy training and a level 3 in energy efficiency to retrofit traditional buildings. Normally, the assessor is the first person who will go and review a site, and from that they will produce a report which will outline the general conditions of the property. You then have the retrofit coordinator. The retrofit coordinator is probably the main puzzle piece in the roles. They're the person who is ultimately responsible for making sure that the dwelling is retrofit correctly. And so they are at the top of the tree in terms of hierarchy and will be involved throughout the process. It's also important to note that actually the same person can do multiple roles, but the conflict of interest does need to be managed. So the third role is the retrofit designer. So retrofit designers can come from multiple different professional backgrounds. So you've got architectural technologists, an architect, building surveyors, Chartered Institute of Building, professional members, and again, the level 3 in energy efficiency of retrofit traditional buildings. The retrofit designer is essentially there to quality assure the proposals that the coordinator is proposing, to make sure that the building isn't going to come to any harm, and to provide a little bit of an oversight piece to the retrofit coordinator. I actually forgot to mention the coordinator has to go through a accredited scheme to get trained. So that's the level 5 retrofit coordination and risk management. So the fourth role is the retrofit installer. So the retrofit installers are the ladies or gentlemen on site who are installing the measures, and they must hold the PAS 2030 accreditation. And the last role there really is the retrofit evaluator. So again, could have the same training as the retrofit coordinator or level 3 in energy efficiency and retrofit of traditional buildings. The evaluator will come in at the end of the process to make sure that all the documentation has been coordinated properly, and that essentially the retrofit is signed off. So believe it or not, this is a simplified approach to PAS 2035 and how it works. So I'm going to run you through what this means, hopefully in a simplified way. So as I mentioned, you will have the retrofit assessor who will go to a site and will undertake that first line of responsibilities. So the preliminary considerations, the project's inception, the engagement advice. That will be done side by side with the retrofit coordinator, but the retrofit assessor will be the one who goes onto site and collects the data for the retrofit coordinator to inspect. The coordinator will then look at the property, look at the potential measures, the energy efficiency measures, and decide whether their property should be a risk A, B, or C. The C being most risky, A being hopefully quite a simple retrofit process. Normally path A only has like one measure. Path C, however, could include listed buildings, building in conservation zones, or buildings with 5 or more measures included. So once that is done, a dwelling assessment will be done. So for the dwelling assessment to be done, there will be a coordinated approach. So the retrofit coordinator has proposed their various measures. They've assessed the risk level. They've put together what is called an improvement options evaluation and a medium-term plan. So this is multiple pieces of documentation which I'll introduce you to in a moment. And then this goes to the retrofit designers on the project. There can be a little bit of back and forth here just with trying to understand the significance of the property, and also just trying to get all the data to make sure that's a collated piece before it goes to the designers on the project. So then the retrofit designers will come in. They will normally put together a report which hopefully just confirms the retrofit coordinator's intent, but we'll cross-check that just to make sure nothing risky is being proposed. And then normally they will also put together a scheme which includes ventilation design, because ventilation is very, very important with changing the building fabric and energy efficiency measures on a dwelling. And sometimes, depending on the designers, you will also receive calculations of heat loss calculations and specifications on the type of products to be used or the building regulations to be met to achieve the desired design outcomes. That will then go back to the retrofit coordinators and the installation process will begin. So that is where really the build comes together, and should hopefully everything should be aligned if everybody is discussing all these different elements together. And then the final stage, once it is finished, is the monitoring and the evaluation and the handover of advice. An important part of all of this process is educating homeowners. So there is, of course, we're trying to improve the energy efficiency of the dwellings, but we're also trying to educate people on how they use their dwellings, what temperatures rooms should be set at, how to be mindful of use as well, and also empowering homeowners. It's important to know that the retrofit coordinator isn't just coming in and saying this is what we should do. They're advising, they're talking to those occupants and really understanding what it is that they want and what is suitable for their property. So this is just a summary of the type of information that would be being collected, that the retrofit coordinator would be putting together. So there would be a condition report, which actually comes from the assessor, but in this there would be comments on any damp or moisture issues, like the current ventilation installed, and pictures of the property. You then receive an energy report, which has the current EPC ratings and then the proposed EPC ratings once the selected measures have been installed. The improvement options evaluation, which is the image to the right hand side there. This is used in addition to the energy report because the EPCs aren't always that accurate. So the improvement options evaluation uses PHPP, which is passive house planning package, and is thought to be a little bit more accurate. So by using this, they work out the simple payback measures and the cost effectiveness of measures, and then also look at the carbon which would be saved from each of these measures to work out the most suitable options for the property. So once all of this has been considered, there will be an assessment summary. In the assessment summary, the selected measures will be chosen, and the RC will normally add reasons behind the selections, just so we have a little bit of a dialogue of what is going on with this dwelling. And if later on we call it the medium-term plan, there are later measures they would recommend, this would be included in this also. The purpose of PAS is to, with the whole building approach, is to understand that it is likely to be a staged approach. Most people aren't going to have the money to retrofit the whole property in one go. So it's understanding how this can happen over a period of years to meet 2050 and onwards, really. So yeah, we've also got the RDSAP, which is further evidence, and floor plans. So in the floor plans, there will be the room dimensions, window and door openings, room heights. So multiple purposes, obviously, to get a bit of an understanding better for those teams who haven't been on site, what this property looks like. But also so the contractors who come on can price for their works using the dimensions, and also the designers can do their calculations, their heat loss calculations, using the data provided on opening sizes and room sizes. So quite a lot to take in. This is an example of what a designer's report may look like. The measures interaction matrix is something that has to be done and is part of the PAS scheme. So in this, it's either the designer or the retrofit coordinator, but both should be agreeing on it. The measures that are proposed are input into this matrix, and you are given a color-coded system. So green is great, they're independent, they're good to go, the measures shouldn't cause any issues with one another. Fine. on the other end, you've got red measures. If any of these measures came in red, they shouldn't be being undertaken, and that design or those proposals needs to be reconsidered. Again, it's just another piece to try and help with the coordination side of making sure that these properties are being retrofit properly and that the homeowner can be secure in the process. And so just on the right hand side there is from an example of what our team would produce at the end of one of our reports. So that would be a summary of proposals. It's really important to know that although the data is good, when it's not great, a lot of the time there is another level of surveys that is needed to really make sure these designs are being done properly. It's most of the time we see a lot of damp in these properties. It's really important to understand where the damp is coming from. If you've got a damp building fabric, you should not be implementing any energy efficiency measures. First of all, you need to make sure that that property is in a good state. By increasing air tightness, you are likely to exaggerate the damp problems inside. And yeah, obviously not what you want to be doing in terms of health, well-being for those people. So damp surveys is a very important one. Asbestos, any buildings pre-2000 should be having an asbestos survey to make sure those people on site are safe. Thermographic surveys, which help with informing the design of the project, and yeah, so on and so forth. It depends on the project and the proposal, but it's important to make sure that information is being collected and those surveys are being undertaken prior to the design. And then at the bottom there is just like a summary of the measures and the dependencies on what should be being done alongside those measures. Ventilation, as I mentioned, is always required to make sure the airflow is sufficient within the dwellings. Okay, I'm wary that's probably a little bit of an overload. So to hopefully finish off, I'm just going to run you through these 3 case studies. So the first here is it's an end-of-terrace Victorian dwelling. It's owned by a young couple. The boiler is old and is broken. The couple are cold, therefore. Windows are single glazed and there's only 100 mil of loft insulation installed. The budget for the project is 5k. So we would, from looking just quickly at this project, we can make a few assumptions. So we can see that the brickwork here is a short and long formation. So it's very likely that this is a solid wall construction, which is typical for that era as well. So we could be quite confident in assuming that. So we can think to ourselves, oh, okay, so one of the best measures here, so we could propose external wall insulation. We could wrap that property, that would help with making those cold walls warmer. We could look at the single glazed windows, like obviously not the best performing windows. We don't know if draft proofing in this instance could be sufficient. We don't really know. But we do know that the budget is only £5,000, and for £5,000, new windows and external wall insulation aren't going to be viable measures. So in this case, what we have to do is we have to look at priorities, and the priority is that boiler. If the boiler is broken, those occupants are cold. That is not a healthy and a well environment. So it may not be what we would typically class as retrofit in improving the energy efficiency of the dwelling, but we need to make sure those people are in a healthy environment. So we would propose that the boiler is fixed first. And then loft insulation is generally a more cost-effective measure. So 100 mil isn't going to meet building regs, normally we advise about 320 mil. So we would say a loft top up or a loft insulation replacement would be a suitable measure for this property. So the second example, sorry, the picture's slightly pixelated, is a semi-detached 1970s dwelling. We have a young family who want to retrofit this property, have 30k to spend, and want to do as much as possible. So, as is quite typical of this time, this property has cavity wall, but there's no cavity wall insulation installed. There's old double glazing, and there's again 100 mil of insulation. So there's a few measures that we could, for that budget, propose straight away. We could propose the cavity wall insulation. We can, providing that those cavity walls meet the requirement of the exposure zones and the cavity widths, that would benefit the performance of this dwelling quite a lot. We can be improving and build, like either replacing or topping up the loft insulation. We can be looking at the performance of that double glazing. When was that installed? Does that double glazing have trickle vents? Do those trickle vents need to be retrofit onto these, or are the windows blown and need replacement? Like that would be a good exercise to understand and help with the performance of this dwelling. Once we are comfortable that the performance have been improved enough, we could then possibly look at changing over the heating system to a renewable heating system. And that obviously depends on a lot of interdependencies, but it would be the aspiration for the project. And with a 30k budget, there potentially is room to do that. Okay, and the last case study is a bit of an unusual one. So this is a detached cob wall dwelling, which has had cement render installed around it. There's an elderly couple who are living here who are cold. There's mold present throughout the interior. Windows are double glazed. There's 300 mil of loft insulation. So we would look at this, and we know that earth walls should be breathable, which means they're vapor open, moisture can travel inside and out, which is generally how older buildings were constructed, and ones with natural materials. So the fact that this has been retrofit with a cement render, which at one point was quite common practice, this has stopped that performance happening. The water vapor can no longer travel in and out, and it's likely that the mold present throughout the interior is happening because of this. So our first port of call with this would be to remove that cement render and try to let this building breathe and dry out again, so it's so it goes back to being functional, and hopefully with an assessment of the ventilation that should help to deal with the mold throughout the interior. We know that the double glazed windows are good, the 300 mil loft insulation is good, and with a budget of 10k, it would be very, very tight, maybe very unlikely that the removing the cement render would be possible, but it would be a priority over anything else happening. So yeah, thank you all for your time. I hope you've taken away a few nice lessons learned. I think it's just really important to understand like the bigger picture of why we're trying to retrofit these dwellings and achieve these 2050 targets, but also understand that it's a complicated, and there's a lot to it to make sure that these dwellings are being retrofit properly and considering every occupant's individual requirements. So thank you again.